Well, the Columbus lab is set to blast into space tomorrow, but the James Webb Space Telescope won't be launched until 2013. Now, that may seem like a long way off, but the engineers making it still have one fundamental problem to solve: how to prevent it from blowing up in space. I know that sounds a bit dramatic, but it could really happen. Inside this average-looking physics lab, Professor J.R. Dennison and grad student Ryan Hoffman are trying to make sure one of the most powerful telescopes ever made doesn't blow up.
The craft itself, I think, is at the $4 billion US dollar mark. So we've got to get it right the first time because there's no going back.
The James Webb Space Telescope is set to launch in 2013 and will literally go where no man has gone before, 1 million miles from Earth.
It's meant to replace the Hubble. It's meant to peer at the origins of the universe.
The big difference is that Hubble is practically in our backyard. It orbits 575 kilometers above Earth. JWST will be 1.5 million kilometers away, where it will be twice as cold.
The environment out there at this particular orbit is not as well known as like where the space shuttle flies, the near Earth orbit. But we do have some idea of what it's like out there.
What has them worried is the constant buildup of static charge in space with nothing to ground to.
If you rub your feet across the floor, you build up a lot of static charge, and you can arc to a light switch or something. In space, there's really nothing that you can dissipate that charge with, so it could arc to something important, like the controller, or could do all kinds of crazy stuff. They estimate that about 1/3 of all spacecraft failures are due to just random charge buildup that arcs somewhere bad.
As the telescope orbits, electrons are absorbed by an umbrella-like sun shield. The more electrons crowd onto it, the greater the danger for a massive static charge. The extreme cold adds to the problem. It slows down the electrons, creating a kind of log jam. But just how much charge will build up is the billion-dollar question.
That's really the question we're trying to answer, is what, and I don't have an answer yet to that. It'll build up some amount of static charge. We're trying to quantify how much. Because if we know how much, then the engineers can go and do what engineers do, and they can fix the problem.
In this vacuum chamber, they simulate a space environment.
These are samples that we prepared for the James Webb Space Telescope. We're just getting ready to introduce them into the vacuum chamber where we can simulate the environment that they'll see. And these three right here are just representative of what materials they're interested in. This is silicon-coated Kapton.
Kapton is a fancy plastic insulator which is commonly used in spacecraft, and what the shield will be made of.
Well, the material we're testing is going to be part of the sun shield, which just provides a big patio umbrella for the instrument itself. And when it goes up, it's going to build up a lot of static charge on it because just interactions with space.
Mimicking space here on Earth is tricky. Liquid nitrogen inside the vacuum chamber brings the temperatures down to about -190 Celsius. The pressure inside is about 1 billion times less than atmosphere pressure.
Well, this particular test that we're doing is called the photo yield. What we do is we shine light on the sample, then we measure how many electrons come off of the sample.
In just a couple of hours, they can deliver as much charge to the test material as a telescope would experience in a decade.
Well, we're pulling out the sample carousel right now, and it's so cold because we've just been dumping liquid nitrogen through it. That's why it's got the frost all around it, and I really can't hang on to it for too long. I'm not sure what the temperature is, but it's probably -40, 50, something like that. So it's very cold.
Their testing has shown that in extreme cold, it can take electrons months, even decades to pass through Kapton, the thickness of a piece of paper. Adding a layer or coating of a conductive material is one idea being tossed around to speed that up. And the pressure to figure it out is on.
It depends critically on what we do, just as it does on what 100 other people are doing on other aspects of the project. If we get it wrong, the mission fails.
Now, from a space machine that hasn't been launched yet to one that's been up there a long, long time. After being